Okay, so we're in section 2.7. So we're going to look at solving inequalities, not equations, but we'll still use equations to help us. So I think the best way to kind of get an idea of what we're doing is to look at a graph, and then the graph, I think, helps make it kind of, a little bit more tangible. So here's a sample problem. Let's say we're given this inequality. We're asked to solve. Okay, x squared minus 4 is greater than 0. Solve for x. Okay, so this is a typical inequality that we'll be asked to solve. And so what I want to do is just kind of go through the steps. What would we do here in a second. But before we do that, let's look at the graph to understand what it's saying. All right, so all I'm going to do first is I just want to look at the graph of x squared minus 4. So what does the graph of x squared minus 4 look like? Parabola down 4. Okay. That opens up. All right. What do you think this is asking for? Yeah. Let me get next. Just get mine. Yeah.
All the numbers greater than 0 on the graph.
Can you be more specific?
All the numbers y above the x-axis.
All right, so here's what it's asking for. What were you going to say?
I was just saying, all of the y's are 0.
Yes, you're looking for, but it says solve for x. So you're right. This is your y's, right? X squared minus 4 is what gives you your y's. But it's saying, give us the x's that give the y's that are above the x. So you can see the graph. Here, it's above the x-axis, right? And here, it's above the x-axis, right? That's what greater than 0 means, okay? So we can see where's the graph above the x. But we don't want to give, we got to know specifically what we're finding. We're finding the x's for where this graph is above. So what might be a key x that we would need? What might be an important x? Yeah, the x-intercept, because that's where it changes right here. That's where the graph changes from below to above. So we're going to give the x's for where the graph is above. So I can see that the graph is above the x on this interval. And we're going to give interval notation when we give our solution. So when you solve for this, we're going to put our answer in interval notation. Okay? So what x is way out here? All right. What x is this?
That's -2.
That's -2, right? This, hopefully you would see that. What x is this? What x is way out here? Infinity. So the graph is above the x for what? The graph is greater than 0 for what x's? All right, would you put parentheses or brackets at -2? Okay, greater than, you don't want that point because it's equal to 0 there. And then I put the union symbol, and then I put 2 to infinity, just like that. And I wouldn't include 2 because I want to be bigger than 0, not greater than or equal to 0. Now that's how I would solve it graphically. Okay. Now, if it had said less than or equal to 0, what interval would that have been? If it said less than 0. Where's the graph below the x? -2 to 2. Brackets or parentheses, depending on if it's equal to or not. Okay. So that's using the picture to solve. What we're going to do is, some of these graphs can be complex and we don't want to have to sit there and waste time trying to graph it. But does everybody understand that the x-intercepts are the boundary between where is it bigger than 0 and where is it less than 0? So that's what we're going to find. So now let's look at, so this really all I wanted to do is just maybe do 1 or 2 looking at the graph. So now how would I solve this same inequality, but do it analytically, by hand? Okay, not looking at the picture. So here's what I'm going to do. So I have my inequality. The first thing I'm going to do is just set equal to 0, and solve. I call those boundary points, so I'm gonna find boundary points. The book calls them cut points. I've never heard of cut, but I guess where you would want to cut the graph into separate parts, I guess, I don't know. So I'm gonna just set it equal to 0 and solve. Well, best way to solve this is by factoring x minus 2, x plus 2. We already know these solutions, right? So we would get 2 and negative 2. Okay? So that's the first step when I'm doing these inequalities by hand. The first thing I'm gonna do is set it equal to 0, and I'll solve and find the boundary points. So these are my boundaries. Now, the second step I'm gonna do over here. So the next thing I'm gonna do is plot the intercepts on a number line, okay? And then the third step is I'm going to test x values in each interval. I'm going to plug into the original inequality. I'm going to plug in to the original inequality. If true, shade. False, don't shade. So let me explain, or let me show you steps 2 and 3, and how steps 2 and 3 are going to correspond to the picture. So when we see the picture, we can see where it's greater than 0. All right? So here's step 2. So I'm going to just put it under the graph here. I'm going to put a number line. I'm going to put negative 2, and I'm going to put 2. I'm going to actually put an open circle at both of those. The reason I'm putting an open circle is because I know that I cannot equal to 0. Okay, so since it says, where is this greater than 0, I wouldn't want to include those solutions. So what the number line is going to tell me is this. It's going to, if I test any x in this interval, that all should come up with the same value. They're either bigger than 0 or they're going to be less than 0. Any x in here can't equal to 0 because I know these are the 2 spots where it equals 0. So I'm just going to pick an x here, say negative 3. And I'm going to plug it back into this, my original statement, my original inequality. And if I plug in a negative 3, I get negative 3 squared minus 4. Is that greater than 0? Well, I get 9 minus 4. Is that greater than 0? I get 5. Is that greater than 0? Yes. So that means if that x is greater than 0, then everything in this interval is greater, and I go ahead and shade, and that shade is my solution. See how this right here goes with this interval that we saw, okay? So that's what I'm saying. Test x values in each interval, plug into the original inequality. If true, you shade. If false, you don't shade. What should happen here? When I test an x in this interval, what should happen? True or false? False, because it's not greater than 0. What would be a good x to try? So you have to pick an x in this interval and test it. What would be a good x to try? You can do a negative 1, you could do 0, you could do 1, just something in here. So if we try negative 1, is negative 1 squared minus 4 greater than 0? Is 1 minus 4 greater than 0? Is negative 3 greater than 0? So as soon as you know the answer, it's false. False means you don't shade. It's not part of the solution set. So you're trying to figure out for what x's is this inequality greater than 0, okay? All right, and then the last interval, what would be a good x to pick? 3. So notice I just move on, I don't shade it. Now I go to the last interval. I'm going to pick 3. Is 3 squared minus 4 greater than 0? What's the answer to that? Yes. So I shade. And then the number line tells me my solution. See how this number line corresponds to the solution we wrote. So now you use the number line to write your interval notation for your solution. So last step, use the shaded number line to write the solution in interval notation. Okay. So I did those, stacked them there so you could see how the number line should correspond to what we see there. Now, I want to tell you this, when they'll have you check your number line in the computer, they don't use open circle, they would have done this on the number line. So they would put parentheses there. They'll put a bracket if it's a closed circle. Just know that a parenthesis is an open circle, a bracket's a closed circle. Okay? All right, so let's do another one. So now we're going to strictly do this one analytically. We're not going to do it with a graph. So we're going to solve, okay? All right, go ahead. Negative x cubed plus 9x is less than or equal to 0, solve for x. You just go through the steps that we did. So solve analytically using those 4 steps. Now I'm going to erase this here. How are you going to solve a cubic? How do you solve a cubic equation? That's what we already taught you. You got to connect the dots. You got to remember what I taught you in the previous sections. Okay, so I'm going to catch up to you. So my first step says take your left-hand side, your function here, set it equal to 0 and solve. Okay. Yeah. But always the way I try to solve polynomials is by what methodology? Factor. What can you factor out? You factor out a negative x, what are you left with? X squared minus 9. X squared minus 9 is special because it's what? Difference of 2 squares. And difference of 2 squares will factor how? X minus 3x plus 3, either one. There you go. And now I have my 3 linear factors. I can set each factor equal to 0. And I get x is 0, 3, and negative 3. Okay? Those I refer to them as what? Boundaries. These are the boundaries. This is where your graph is 0. You're looking to see where is your graph less than or equal to 0. So now the second step So that's step one. The second step, I then take a number line and I plot those solutions on a number line. And I'm going to put a closed circle because it says less than or equal to 0. And now I'm trying to see where is the graph below the x, because the x-axis is 0 in terms of the y's. So where is it below? So now I'm going to test. Now, a couple of things. You can either, when you go to test, you can when you're testing, you can test your original or your factored expression. See, it might be easier to plug x's into the factored part because then you're just multiplying rather than having a cube. It's up to you. Just make sure I haven't eliminated any signs, so that negative still needs to be here. So what would be a good x to test right here? So look, if I do -4, I can see the three numbers that I'm going to get. I'm going to get 4 times -7 times -1. And at the end of the day, I'm just trying to see, is it bigger than 0 or less than 0? So when I plug it in, a -4, I get 4 times -7 times -1, which is 28 is less than 0, which is greater than 0. Thus, this is false. So I don't shade. Understand? It's as simple as that. You're just testing x's. Then I'll go here and I'll test -1. So I'm going to have 1 times -4 times 2. And that is -8, which is less than or equal to 0, so I shade. Okay? Now I test 1. I got -1 times -2 times 4. That's positive, not less than 0. Then I'll plug in a 4. -4 times 1 times 7 is -28, which is less than or equal to 0, which is true. And there's my two intervals. And I need to just write those in interval notation. I'm going to take that number line and now write the interval. So my solution is what? So the solution for this is, anybody? Bracket -3, comma 0, bracket union, bracket 3, comma infinity. Guys, we got to get with it. So otherwise, I'll just talk to myself and film and just show you the videos. So the point of doing it in classes, we'll have a little back and forth and it makes the flow a lot better. All right, here's your solution. Okay? Got it? We'll do another one. I'm going to erase the steps. Hopefully you have them because you're not going to see these steps anyway. All right. Example 3. Same thing, except here's my inequality. All right, now, same request, solve for x. There should be a span of solutions, but there's something you should do first. What do you think you should do first, Andrew? Yeah, how did you do that? Just subtract it. Yeah. So bring the 8 over. Get all your stuff on one side. So on this first step, we're going to take this and bring the 8 over, which becomes -8. And then it's going to be greater than or equal to 0. And then you go through the steps. How many solutions should you get? Should get 3. You could always get a double root. That's possible. So be on the lookout for that. How are you gonna solve it if nothing factors out? Grouping, that's exactly what you do. 4 pieces, you do factor by grouping. Oh, that's a 2x squared. Okay, let's check our work. So if we're gonna do grouping, which is correct, what would you take out of the first group? You're left with what? What would you take out of the second group? You're left with? Now, what comes out of both groups? X plus 2 is the common factor, and that leaves you with x squared minus 4. Now, can you factor x squared minus 4? Yeah. X minus 2, x plus 2. So notice what happens with the root negative 2. The root negative 2 is what type of root? Double root, all right? What happens graphically at double roots? Bounces. Now, we're trying to see, so I'll put closed circles there. I'll test in each interval, and I'm going to test in this factored part, because I think it's easier to plug in right here. So I'm going to plug into the factored expression. Since I haven't canceled any numbers or moved anything over, and that's, I'm going to see where is that greater than or equal to 0. So I'll try to say negative 3. So let's see, if I plug in a negative 3, I get negative 1 times negative 5 times negative 1. 3 negatives multiplied comes out negative. So that's false, right? Then I'll do, well, think. If it's negative 2 is a double root, what does the graph do? Bounces. So if it's already below, it's probably going to stay below there, all right? So when I do, so I'll plug in, say, 0. If I plug in a 0, I get 2 times negative 2 times 2, which is that greater than or equal to 0? So no, so it's still false. However, that is a solution, because it says, where is it greater than or equal to 0? So I'm going to have to give the number negative 2 when I answer this. I'll show you how we write it, okay? Because negative 2, it equals 0. The question is, where are we greater than or equal to 0? So I got to give negative 2. And then the last one, I'll plug in a 3, and I get 5 times 1 times 5, which is greater than or equal to 0. And I'll shade, shade, and shade. So there and there. So my solution on this is going to be x equals negative 2, and then bracket 2 to infinity. You see where it's kind of weird, but you got to give the negative 2 because it equals 0. Now, had this just said greater than 0, then I would not have given it. Yeah, I think it'll probably set you up. It'll help you out with this, because this is kind of weird. You could just put, yeah, x is just -2 union bracket 2, yeah. Probably that. It's weird, you don't commonly get that type of an answer. So we'll see how it asks you to do it, okay? All right, now we're gonna do rational inequalities, which is pretty much the same as this. It's actually a little bit shorter, I think. It's not that bad. Okay, so let's do one of those, and then we'll stop there before we do a couple of application problems. All right. So really, the methodology is the same, okay, for the most part. You're gonna find those boundary points, except with rational functions, you can now have asymptotes. So we use those as our boundaries. Okay, so here's a typical problem. So example, I think we're on example 4. Again, solve for x. And let's just say we have x plus 1 over x plus 3. Where is that less than 2? Now, same idea. Okay, we don't want the 2 on the right-hand side. We want to have what on the right-hand side? 0. So the first thing I'm going to do here is just bring the 2 over. So I'll make it x plus 1 over x plus 3 minus 2 is less than 0. Now I'm going to do a little bit more setup before I go through and solve and all that. So I am going to set this equal to 0 in just a second, but here's what I'm going to do. The first thing, since I have a rational function, I have a fraction. It's going to be a lot easier if we just make this into one fraction, and we look at the top, and we're going to look at what makes the top 0 and look at what makes the bottom 0. Because we want that vertical asymptote as a boundary, because that's also a boundary. Because think, when you did these problems, when you had vertical asymptote, a lot of times the graph split there, and that's where it changed from maybe above to below. So that's another good boundary point to look at. So my first thing here, before I even get started, make into one fraction. And the way you do that is you get a common denominator. So so you're going to do x plus 1 over x plus 3 minus 2. It's like 2 over 1. And then we're going to set it equal to 2 things. We're going to set the top equal to 0 and the bottom equal to 0, which is undefined. Because we want to get all those values, because those are going to be our boundaries. But the first thing I have to do is get the common denominator. What's the common denominator? X plus 3. So multiply top and bottom of this by x plus 3, make it to one fraction. Set the top to 0, set the bottom to 0, that's it. Okay? So we get our boundary points just a little differently from a polynomial. All right, let's see what we get here. The denominator is x plus 3. The top becomes x plus 1 minus 2x minus 6. You distribute -2 over x plus 3. We're going to set the top to 0 and the bottom to 0. So it's a little different because we want that vertical asymptote as a boundary. okay? All right, and I got negative x minus 5 on top, and I have x plus 3 on the bottom. So we're gonna set the top to 0 and set the bottom to 0, okay? I'm gonna check my work there, check your work, make sure we got it on the same. So you get the common denominator of x plus 3, you gotta distribute your negative 2, x minus 2x, negative x, 1 minus 6, negative 1. Okay? Then I'll do negative x minus 5 is 0, and x plus 3 is 0. And those will be my boundary points. Okay, what are our solutions? What do we get? X is what? And x is. Now, when you go to test these, so we're going to test negative 5, negative 3. Look, negative 3, I'm going to remind myself, that's where the graph is undefined. So you can't get an answer there, right? The graph, that's where there's the vertical asymptote. So I'm going to remind myself that there's no point there, it's just a boundary. So I'm even putting a dash here. So I can't give, you know, even if this was like a less than or equal to, I wouldn't give that as a solution. Now, negative 5, I'll put an open circle. Now, the question is, where do I test? Well, you don't want to do this because we want to compare it to 0. You could plug in here, or you could use the simplified where it's one fraction. I think this is a bit better to use because it's just one fraction. And they're going to ask for this new inequality. They're going to say, hey, move this over. What's the new inequality you get after you move 2 over? They're going to test you and see if you can give this, okay? So I'm just done. So I would probably plug into this rather than this. Doesn't matter. You don't get the same answer. All right, so now I got to test. I have 3 intervals. What would be a good x to test over here? Yeah, so everybody understands the process is the same. The only thing that's different is you're going to set the top and the bottom to 0 of your one fraction. And those are your boundary points, okay? All right, so negative 6, so let's see, it would be negative 6 minus 5 over negative 6 plus 3. Is that less than 0? I got 1 over negative 3 is less than 0. So that's true. All right, what would you test in here? Negative 4, so let's see. So if we test the negative 4, is negative 4 minus 5 over negative 4 plus 3, is that less than 0? Let's see. 4 minus 5 is negative 1. Negative 4 plus 3 is negative 1. Nope, not less than 0, okay? And then anything right of negative 3, you test, so I'll test like 0. So is 0 minus 5 over 0 plus 3 less than 0? Yes, you get negative 5/3. Okay, so see, we needed that boundary to tell us because that separated the graph. If we didn't have that boundary, we would have got it wrong. And then now you know how to write the answer. Just write your answer in interval notation. That's it. Okay. So what's our answer? So I want to re-emphasize. Have this been equal to? What would change? What would change here? Nothing. Very good, because it's undefined. So just make sure the only difference is on these, we set the top to 0. I think I emphasized it here, and the bottom to 0 to get our boundary. and these are your boundaries. Okay, and we remember from rational functions that whatever makes the denominator 0 is a vertical asymptote. Okay, so I'm gonna stop there, that's part one, and we're gonna, the second part is much shorter.